Welcome to Machine Learning Engineer series. In this series, we are going to start from the absolute basics and gradually go all the way to advanced machine learning engineering. We will not just learn how to call a machine learning library and train a model, we will understand what is actually happening behind the scenes. We will learn the mathematics, algorithms, deep learning, transformers, LLMs, ML ops, deployment, monitoring, and eventually how to build production ready ML systems. But before all of that, we need to answer the most basic question. What exactly is machine learning? Machine learning is a way of building systems that can learn patterns from data and use those patterns to make predictions or decisions. The important word here is learn. In traditional programming, we usually tell the computer exactly what rules it needs to follow. In machine learning, instead of manually writing every rule, we provide examples and allow an algorithm to learn useful patterns from those examples. Let's first understand traditional programming. Imagine we want to create a program that determines whether someone gets a discount. We might write a rule: if the customer's purchase is greater than 5,000 rupees, give a discount. So we provide the computer with the rules and the data. The program follows those rules and produces the output. This works very well when we understand the rules of the problem. Now comes the problem. There are many situations where writing rules manually becomes extremely difficult. Consider spam email detection. What exact rule tells us whether an email is spam? Maybe it contains certain words, maybe it has suspicious links, maybe the sender is unusual, maybe the email has strange formatting. There could be hundreds or thousands of factors. And even worse, spammers continuously change their behavior. So, manually writing every rule is not practical. This is where machine learning becomes useful. Instead of manually writing all those rules, we give the machine learning algorithm many examples. For example, we give it thousands of emails. We tell the algorithm which emails were spam and which were not. The algorithm looks for patterns in the data. Eventually, it creates something called a model. Then, when a new email arrives, we give that email to the model. The model uses the patterns it learned to predict whether the email is spam. Let's take a simple example. Imagine we want to predict the price of a house. We collect historical data about houses. For each home, we might know its area, number of bedrooms, location, age, floor, and many other properties. We also know the actual price at which the house was sold. We provide these examples to our machine learning algorithm. The algorithm looks for relationships between the characteristics of a house and its price. Now, let's introduce two very important terms that you will hear throughout this entire series. The information we use to make a prediction is called features. In our example, area, number of bedrooms, and location can all be features. The thing we are trying to predict is called the label or sometimes the target. Here, the target is the house price. So remember, features are what we use to make the prediction. The label is what we are trying to predict. The model doesn't simply memorize one house. It tries to learn relationships and patterns. For example, it may discover that large houses tend to have higher prices. It may discover that certain locations tend to be more expensive. It may discover that additional bedrooms generally increase the price. These relationships are captured inside the trained model. And then we can use that model to make predictions about houses it has never seen before. This process is called training. During training, the machine learning algorithm looks at the available examples and adjusts itself to learn useful patterns. The data used during this process is called training data. At the end, we have a trained machine learning model, and this distinction is extremely important. The algorithm is the procedure used to learn, the model is what we get after learning from the data. Now imagine a new house enters our system. Maybe it has 1800 square feet, 3 bedrooms, and is located in Bangalore. We give these features to our trained model. The model applies the patterns it learned during training and produces a prediction. Perhaps it predicts a price of 1.25 crore. This is the basic idea of machine learning. Learn from historical examples, then use what was learned to make predictions on new data. These are two stages we should clearly separate. First is training. During training, we have historical data and use an algorithm to learn a model. Second is prediction, sometimes called inference. During inference, we take new unseen data and pass it through the trained model. The model produces the prediction. This distinction will become very important later when we talk about deploying machine learning models in production. Now let's clear up a very common confusion. People often use artificial intelligence, machine learning and deep learning as if they are exactly the same thing. They are related, but they are not identical. Artificial intelligence is the broader field of building systems capable of performing tasks that normally require some form of human intelligence. Machine learning is a major approach within AI, within artificial intelligence, where systems learn patterns from data. Deep learning is a subset of machine learning that uses neural networks with multiple layers. So, a simple way to remember it is AI is the broader field. ML is a major approach within AI, and deep learning is a subset of ML. Machine learning itself has different approaches. The first major category is supervised learning. Here we train using examples where the expected answer is known. For example, houses with their actual prices. Another is unsupervised learning, where we don't have an explicit target label and instead try to discover patterns or groups in the data. Then we have semi-supervised learning, self-supervised learning, and reinforcement learning. We will study each of these properly later in the series. Supervised learning is one of the most widely used forms of machine learning. We have input data and a known expected output. The model learns the relationship between them. If we are predicting a numerical value like house price, we are dealing with a regression problem. If we are predicting a category like spam or not spam, we are dealing with classification. Regression and classification will be some of the first algorithms we will study in detail. In unsupervised learning, we don't necessarily have an answer column telling us what the correct group should be. Instead, we ask the algorithm to find interesting structure in the data. For example, imagine an online shopping company has millions of customers. We might give the algorithm information about their shopping behavior. It could discover groups such as frequent high value customers or occasional customers and customers who mainly buy during discounts. The algorithm discovers these groups based on patterns in the data. Machine learning is not limited to research labs. It is already part of many systems we use every day. Recommendation systems decide which videos or products to show us. Banks use machine learning for fraud detection. Email services use it for spam detection. Computer vision systems can identify objects in images. Voice systems convert speech into text. And modern generative AI systems, including large language models, are also built using machine learning and deep learning techniques. But here is something extremely important. Real machine learning engineering isn't just about choosing an algorithm. A real ML project usually starts with a business or technical problem. We collect data, we clean and understand the data, we create useful features, we train a model, we evaluate it. Then, if it's good enough, we deploy it. And we are still not finished. Once the model is running in production, we need to monitor it and potentially retrain it as the world and the data change. This complete life cycle is what we will eventually learn in this series. One misconception I want to remove right now is that machine learning is simply about choosing an algorithm. In real world projects, getting good data can be extremely difficult. You can have a very sophisticated model, but if your data is poor, the model may still perform badly. You also need to think about evaluation, deployment, latency, scalability, and monitoring, cost, and reliability. That's why we are going to learn both machine learning theory and engineering in this series. So what's exactly we are going to learn? We will start with Python and the mathematics needed to understand machine learning. Then we will learn how to work with data. We will implement classical machine learning algorithms. And then we will move into neural networks and deep learning. We will learn computer vision and NLP. We will understand attention and transformers. And then we will move into modern AI LLMs. And finally, we will focus heavily on ML ops, deployment, monitoring, system design, and production machine learning. We are not going to stop at model.fit or model.predict. Libraries are extremely useful and we absolutely will use them. But before relying on libraries, I want you to understand what is happening underneath. Whenever possible, we will understand the intuition, mathematics, and algorithm, implement important concepts ourselves, and then use production libraries. The goal is not just to make a model work. The goal is to understand why it works and when it fails, how to build it properly in a real system. So, what does an ML engineer actually do? An ML engineer sits at the intersection of machine learning and software engineering. You need to understand data, you need to train and evaluate models, but you also need software engineering skills. You need to build APIs, pipelines, and services. You need to deploy models, you need to monitor them, and you need to think about scalability, reliability, latency, and cost. That's why becoming an advanced ML engineer requires more than knowing machine learning algorithms. If you remember only one diagram from today's video, remember this. We start with data. Machine learning algorithms learn patterns from that data. We get a model. The model makes predictions. Those predictions are used inside real applications, and those applications generate new data. That new data can eventually be used to improve the system. So, machine learning is not simply a model, it is a complete cycle. Let's quickly summarize today's video. Machine learning allows computers to learn patterns from data. Features are the inputs we use, labels are the expected outputs. In supervised learning, training is the process of learning from examples. The trained model is then used to make predictions on new data. And machine learning engineering goes beyond the model itself. It includes data, software engineering, deployment, monitoring, and production systems.